Good afternoon, ladies and gentlemen, here in Silicon Valley at 13th Cloud Expo, 4th International Big Data Expo, and more besides. Here we are, afternoon of day 2, so we're not even halfway through the huge amount of content that we're serving up. Delighted to have the chief scientist and co-founder of SoftLayer with us. Performance is not a commodity. I've been pondering this one, and I don't know which way this is going to go. So let's give it up, please, for Nathan Day, and please tell us about this. Thank you.
All right. Well, thank you for the introduction. I appreciate it. So I'm chief scientist, one of the co-founders of SoftLayer Technologies. We are now SoftLayer, an IBM company. The biggest difference in my life so far since being acquired by IBM is that I now wear blue shirts when I come present. So today I want to talk about performance and clouds and how it relates to you. I've got some data to show. I've probably got too many slides, so I'm going to dive into it and try to find some interesting ones. So when I was preparing this presentation, for about 5 seconds, I thought about defining the cloud. And then I realized it's 2013, not 2008, and this is one of the longest standing cloud conferences, and I don't need to define cloud for anyone in the audience. What's a more interesting conversation to me now is trying to figure out what cloud is not. A lot of people have this expectation of what they think cloud is. And so I went and got the National Institute of Standards and Technology's definition of cloud, and I started to find some things that aren't in there. What's not in there? Cloud does not have to be virtualized. You don't have to have a hypervisor in the stack for something to be cloud. Cloud does not have to be off-premise. The only mention that might make you think cloud had to be off-premise was that mention in the definition there about having shared resources. These can be internally shared resources. Cloud can actually be on-premise as well as off-premise. And cloud does not have to include noisy neighbors. Just because it's shared doesn't mean that you have to suffer if your neighbor is using the resources that you're sharing. And one thing I should have added but didn't, and I looked at this very carefully to make sure this wasn't in here, cloud does not have to be at Amazon. So there are a lot of types of clouds. I thought about sticking the vendors' names up here, but I couldn't figure out which one would go where. I didn't figure out which one would be Amazon. There's so many varieties. I mean, just go out in the expo hall out there and you'll find, ProfitBrick, SoftLayer, Rackspace, Verizon. You'll find DreamHost is out there. All these great cloud hosting companies that can, hopefully be the type of cloud you need. Each of these providers is a unique snowflake. They've all got their advantages and disadvantages. And hopefully today I can tell you some things to look at so you can decide which one of these providers is right for you, or if you need to do it on your own on-premise. So why do you care about all this? Because of performance. Your application needs to perform. We just saw a great presentation by Akamai about how they can help your application perform on the internet. And they do a great job of getting the bits to the end user with just a huge increase in the performance that you can see. That's just one aspect of performance. I've got a little theory going on with my friends back in Dallas that you can take any problem and simplify it down to a car analogy. So I thought I'd try it with performance. This is a picture of a BMW M5. This is an awesome automobile. It's got over 500 horsepower. It accelerates at an incredible rate. I don't think anyone would argue that this isn't performance. But what's this? Toyota Prius. It gets over 50 miles to the gallon. That's performance too, isn't it? Maybe it doesn't accelerate as fast as the BMW, but I bet that BMW doesn't get that kind of gas mileage. And just to drive a point into the ground, here's a Tata Nano, $3,000. The amount of car you get per dollar far exceeds what you get for the BMW and the Prius. So what I'm trying to get at here is that it really matters what aspect of performance you're looking for. So here's some elements of performance in the cloud. You can look at processing, billing, uptime, network side, how easy to manage. You can talk about security. There's a lot of different elements of performance, and each one of you out there has different needs. You might even be running the same application. If I did a survey of everyone who's running SAP and tried to see if everyone is running the same standard implementation of SAP on the exact same hardware with the exact same response time, I wouldn't find it. Even though you may be running a common application, every use of every application is going to be different. So I'm going to focus in on processing first, just because it's the most natural one. It's what most of us think of when we think of performance. So we're going to focus on compute performance. And I'm going to take that generalization and really look at what's going on inside the hardware. So let's look at the CPU, let's look at the memory, and let's look at the disk. The variables we're going to look at here are things like gigahertz of the processor speed. Whether this is a hypervised core or whether this is the actual bare metal processor, and looking at the individual hardware core, the gigahertz matters a lot. The number of cores matters a lot too. How many threads can you run simultaneously? Some applications would rather have one thread, one core running at 3.5 gigahertz than have 6 cores running at 2 gigahertz. Other applications are different. If you have an application that's well multi-threaded, like most of them today, then you'll be very happy having more cores, even though you might not have the fastest bus speed on those cores. I/O speed, looking at I/O operations per second. This matters a lot too. When you're trying to find a cloud for your application, whether this is, again, off-premise from a cloud provider, or it's on-premise and using OpenStack or something like that, you care about disk performance. And so with a cloud provider, and if you really care about disk performance, can you specify how much performance you want? Someone like SoftLayer or Rackspace, you can design your own disk subsystem. You can get bare metal servers that are operating a cloud model, and you can design what's going on the server, whether you want SSDs or whether you want big SATA drives, if you want a certain RAID level for availability, maybe you want a certain RAID level for performance. Even if you're not talking about bare metal in the cloud, at Amazon, you can buy one of their products where you specify how many IOPS you get for their block storage. That's wonderful. It's really expensive, but if performance of the disk is what matters to you and your application, it's very critical to be able to specify what that's going to be, either through a network storage at Amazon, or if you're doing a bare metal from Rackspace or SoftLayer. So bare metal versus virtualized. There's a tax for running virtualization. Virtualization is a wonderful thing. I don't want to let anyone leave here thinking I don't like virtualization. The convenience of using virtualization and the ability to dynamically provision resources in a hypervisor environment is very cool. It's made the deployment of applications easier. It's just a wonderful thing. But you don't get anything for free. Anytime you put a layer in between the application and the physical RAM, the physical CPU, the physical disk, you're going to pay a price. Now, the hypervisors are getting better every year. That amount of tax is going down, but it always exists. If you look at maybe an in-memory caching application, and you run that inside a hypervised environment, yeah, you're probably getting good performance, but you're not getting great performance because every call to the RAM is going through this extra hop. It's like having an extra switch in your network. So it's something to consider that hypervisors are great, very convenient, but there is a price to pay. And for some applications, the price doesn't matter. For some, it's very critical. So if you want to look at the different models of cloud, you can talk about a virtualized cloud from a ton of providers, many of whom are in the expo hall, except Amazon, who decided not to show up. You can look at bare metal cloud from a couple providers, Rackspace, SoftLayer, a couple more. You can look at a private cloud, and you can think about a private cloud being either on-premise or in a hosted environment. It's kind of an interesting thought. You can take with technology available today, you can build an OpenStack, a vCloud, a cloud platform cloud on-premise, and actually extend that out into a hosted environment. Well, why would you want to do that? You would want to do that to get the extra capacity that a cloud provider gives you. One of the great things about cloud provider is it feels like you have infinite resources available. If you want to spin up 500, 1,000 more virtual machines in an afternoon, you can do that at pretty much all the service providers we've talked about today. You can't do that in your own data center unless you have pre-purchased all that gear and it's sitting there not being used. So this idea of a hybrid cloud, I think, is going to catch on more and more, because you can get the convenience of cloud, but you can also get that feeling of control that you can't get anywhere else. So keep that in mind if you're thinking that this cloud is great, I can use OpenStack and build out my own cloud on-premise. Just remember, you can actually put some elements of that off-premise as well. So how do you do this? As a cloud provider that offers bare metal and virtualized cloud, a lot of people come to me and say, you just can't do that. Well, speaking for SoftLayer and the other service providers out there, yes, we can do it. It's really just a matter of having a highly disciplined approach and doing things using a ton of automation in order to deliver the product that we say we can deliver. So you can go out there and get a bare metal server from a cloud provider, pay for it by the month, and get it in a couple of hours. And that's generally enough. Sometimes people think about cloud, it's got to be billed by the hour or by the minute, and I've got to be able to have it in 3 or 4 minutes. There aren't that many applications out there that really need to spin up in 3 or 4 minutes. It's a great convenience, but do you really need it? Paying by the hour is great too. You can get SoftLayer products by the hour too. But how many applications only live for an hour or two? How many are ongoing? How many people are actually overpaying when they pay by the hour instead of the month? If you look at pricing and you start multiplying that number of hours times the number of hours in a day times the days in a month, you can get a pretty high price just by looking at paying by the hour. And what we've found is most workloads out there, most applications out there, have a degree of steady state workload. And that steady state workload, if you're paying for that by the hour, you're overpaying. Now, it's fine to pay for bursting by the hour, but make sure you don't get stuck in the trap where you're paying hourly pricing for long-term usage. So I want to take a look at just a couple use cases, not many here. And we're going to look at things like speed, consistency, cost, agility, that kind of fun stuff. And a couple of these use cases are storing data. Back in the old days, 4 or 5 years ago, you'd put everything in a relational database like Oracle. And when you needed to grow your Oracle database, you would get a bigger server. You'd add processors, you'd add RAM, you'd add disks. You can cluster them together, but you really can't cluster them for workload. At least you can't scale it very much. And you'd hook it up to a SAN so you could, maybe get a little better performance of the storage. Maybe you can increase the storage. But it's pretty much a scale-up model. Compare that to some of the NoSQL products today, like Mongo. With Mongo, you scale out. Instead of having to grow bigger and bigger elements of your storage, you just add more. And that really gives you a great deal of flexibility. Now, your applications to determine which one of these is going to work for you. If it's a custom application, you definitely want to look at developing under a NoSQL model. If you got a traditional application, you're probably going to have to go with the Oracle scale-up model. Both of them are valid, but please look at this and remember that to look at your application and use the underlying storage platform that works best for you and try to find the right place for it. So how do you do that? How do you know where's the best place for my application, where's the best place for my storage? You have to test. And you know what? You have to test yourself. That is the craziest picture I could come up with for testing. I bet they can test all kinds of things on that workbench. Maybe it's not applicable to cloud, but I thought it was a funny picture. So testing. Metrics are good. You have to get metrics. The least best metrics are ones that are supplied by a vendor. And I say that knowing fully well that in a couple minutes, I'm going to show you some metrics we generated. The next best is get third-party metrics. Now, you got to be careful here. A lot of the third-party metrics out there are sponsored. So you'll get a vendor. We've probably done it too, where you hire this outside firm to write a report. And the reports, I'm sure, are completely accurate. But you know what? The vendor probably chose the use case that fits them best. It's a little self-serving, but what would you expect a vendor to do? However, the best metrics available are ones you do yourself. The great thing about using one of the cloud providers is it doesn't cost much money to go test. For a few hundred, a couple $1,000s, you can get a lot of resources for a few weeks, for a month, and you can test it. And you can test it at a couple different cloud providers. A little harder to test it in your own data center unless you've got extra gear laying around. But you know what? Maybe you want to go to a cloud provider and figure out what the best gear is. Maybe you want to go to a SoftLayer rack space and try maybe single processor servers versus dual processor servers, or even quad processor servers. Maybe that matters, and maybe that'll help you make a decision for your on-premise workloads. But you have to do it yourself. I'm going to go through some testing that we did, and again, these are vendor-generated metrics. But what we did was we built out a Mongo implementation, and if you attended one of the sessions yesterday afternoon by a member of SoftLayer's team named Harold Hannon, he had a lot more details than I'm going to go into today. But I took one of his use cases where we just built out what we thought was a generic sample Mongo NoSQL database. We put some data in it. We used a public cloud provider, not SoftLayer, so a public virtual machine cloud, to compare it to running this on SoftLayer bare metal. I'm going to show you some prices along the way. These are list prices off the websites. There's no reserved instances going on here. There's no volume discount from SoftLayer. It's just straight up off the website pricing. So what we did was we set up a bunch of MongoDB servers, sharded some data across it. We used an application called JMeter to generate load, and we had a test machine where we could actually vary the load. So this performance test we did, you can see the vertical axis is operations per second. The x-axis is number of concurrent clients that we just spun up. And you'll notice that, yes, the SoftLayer solution was more expensive than the public cloud solution, but the performance level far exceeded the cost difference. So SoftLayer is half again as expensive as the public cloud, but you get twice or more of the performance depending upon the workload. We expected that. You're running on bare metal against running on a virtual machine here, or many virtual machines here. One of the interesting things about this graph wasn't that we exceeded the performance at a public virtual machine cloud, was that we were fascinated by the variation of the test results as shown by those vertical bars on the public cloud line. That is a huge difference. How would you like to be the system administrator in charge of the application and you get that kind of variation in how it runs? You wouldn't know if your application is sick or healthy on a minute-by-minute basis. That's really important. How consistent is your application going to be? What are your end users going to expect? So in this use case, the end users of this theoretical application wouldn't know whether to see the results pop up in 2 seconds or 10 seconds. This could be huge. So since we're doing a bare metal cloud here, this was SSDs on the bare metal side of SoftLayer, we actually had the ability, we had the freedom to change the disk subsystem. So we changed the disk format from ext4 to XFS, and we got a huge increase in performance. You can't always do that from every cloud provider. If you're running in a PaaS model, for example, where you're not specifying the underlying infrastructure, you won't be able to have this kind of fine-grained control and control the performance of your application. So this is just something to consider when you're looking at performance of the CPU. Here's that consistency on another slide. The top is the public virtual machine cloud, and the bottom is the SoftLayer bare metal. You can see the huge variation between a public virtual machine cloud and a bare metal cloud. Again, I wouldn't want to be the system administrator in charge of that application, because I'd either have alarms going off all the time, or my users would be knocking my door all the time because they wouldn't know what to expect. Quick price performance. We took Unix Bench, just a standard benchmark, been out there for years, ran it on a couple of varieties of SoftLayer versus a public machine cloud, and you can see that the performance in this, again, generic benchmark. It's not going to hold true for every application out there, but for this very generic benchmark, the performance on bare metal per dollar was far above what you'd get at a public commodity virtual machine cloud. So moving from power to network, there's two elements to network performance. You can look at the local performance inside of a rack. This is going to be critical if you're running, say, Hadoop. If you've got a Cloudera version of Hadoop out there and you're wondering how it's running, you need to look at how it's laid out in the rack. You wouldn't want elements of a cluster like that to be separated by racks or routers or data centers, anything like that. Another element to network is the global element. Again, if you were here for the Akamai talk right before this one, you heard some great examples of how to improve the performance over the wide area network. Back to the local aspect of it, how a cluster is laid out inside a rack, inside a local network, is very important for some applications. One thing you'll find is that some applications, when they're talking to each other, the cluster communication is going on, they really want to be within the same network hop and have latencies of tenths of a millisecond. Others aren't quite so sensitive. Again, you have to test. A couple things to think about is, are you crossing layer 2 or layer 3 boundaries? Is a router included in the path? And some of the big data applications have to worry about something called TCP incast, and that's what you get when all the elements of the cluster respond at the same time to one master. They can actually flood the buffers on the switch. So pay attention to that, whether you're at a cloud provider or in your own data center with your own cloud. The global network, look at the global network of your cloud provider, or if you're doing it your own, figure out how you can have a global network. If you're on-premise and you have one data center, use someone like Akamai or Edgecast or one of the other CDN providers to make your application perform worldwide. If you find a cloud provider with a global network, say you're at Amazon, use different availability zones. If you're at SoftLayer, Rackspace, or some of the other ones, use different data centers. Find ways to load balance your traffic so that no matter where the end user of your application is, they have great performance. Okay, so you're wondering, well, how can I do this without testing? This is one thing that's hard to test. How can I test my application worldwide when my test subjects are all in one location? There's a couple ways you can. There's a company called Sodexis that publicizes some numbers about how different data centers perform on a worldwide basis. They look at things like error rate, time to respond, some other things. Sodexis also has some products that will help you increase the performance of your application. Cloud Sleuth is another one. They look at things like uptime. They look at round trip times for packets. It's another useful tool that you can use. Again, this is third-party data, but you can probably trust this third-party data. Sodexis and Cloud Sleuth are both independent. Let's go to agility. So we've talked about power in terms of the processing and the network. You want to be agile too. If you're on-premise, there's a lot of tools you can use to be more agile. You can use vCloud, Cloud Platform, Eucalyptus, OpenStack. Some of the downsides, you're paying a lot of capital expense and you can't respond very quickly to changes in demand. You do get more control of your architecture, but you'll have less flexibility because you can't swap your infrastructure at a moment's notice like you can from a cloud provider. If you're off-premise using one of the cloud providers out there, your barrier to entry will be low. Your CapEx will be low, your OpEx will be high, but you'll have a lot more flexibility. I tried to rate some of the different aspects of public versus private cloud. Public cloud, you don't have as much control or freedom because you're buying up a product. Your scalability is very good, but the complexity of your operation is low. And compare that to the on-premise private cloud, where you have more control, more freedom, scalability is harder, complexity is a little higher. And a hosted private cloud, this could be if you're running, say, OpenStack at SoftLayer, you're running vCloud at Rackspace, something like that. You can get this nice blend between the two, where you can have more control, medium freedom. You can be very scalable, and you can keep complexity low. So that's something to think of as well. Management, when you're using a public cloud provider, look at their tools, test them out yourself. You can't trust anyone else. No one knows how you're going to use your cloud resources better than you do. Does your cloud provider or does your on-premise private cloud solution have mobile management tools, or do you even care? Maybe that's not an element to the way your system administrators manage your systems. Using an API, same thing as mobile. Is it part of your story? Do you want to have automated access to your infrastructure, whether that's on or off premise? Again, it's going to matter to each of you differently, but it's something to consider when you're looking at using a cloud provider or hosting internally. Cloud management, RightScale. They do a great job. They let you manage multiple clouds. They actually let you manage on-premise clouds for a couple different providers. So if you had maybe a cloud platform stack on-premise and you wanted to use Amazon or SoftLayer, you could actually have those two clouds interact and have that hybrid model we were talking about. If you're thinking about that, I encourage you to take a look at RightScale. Cloud platform is a Citrix product. Cloud Stack, I think, is the open source version of it. You can get, this is going to be true for OpenStack as well, you can get that degree of freedom that you don't have from just as using a provider as is or doing this on your own using bare metal. Business agility is something to consider as well. It comes down to time and dollars. There's a couple tools out there that can help you. A couple companies, Cloudability, Nuvum, that will actually help you monitor your expenses in the cloud. Your CFOs really care about this. If you have lines of business too that are out there buying cloud outside of the normal channels, they can help you get a handle on that and help you manage it. So I didn't hit a lot of the aspects of performance, didn't have enough time, but a lot of it comes down to flexibility. Look at what you need, look at what's out there, and test. Try it on premise, try it off premise, try a bunch of different providers. Go out there in the expo hall and talk to Verizon, Rackspace, SoftLayer, DreamHost, talk to ProfitBricks. They're all out there. They're all going to be able to service you in different ways. Try to find the service provider that has the flexibility you need and performs best for your application. So performance is in the eye of the beholder. You're the beholder. Find out what matters to you. You have to do your own testing. Use some numbers that are out there to maybe give you a little guidance in the beginning, but nothing beats your own testing. And please remember, virtualization is a tool, not a requirement. You can have some very dynamic, scalable applications out there in the cloud without using virtualization. Thank you very much.
Thank you, Nathan. I believe we move into breakout sessions now. Do you want to take some questions, sir? I think you have time. A question for Nathan. It's better that you talk than I do, that's for certain. A hand, I can still see, thank God. So any hands? Help me here, help me here. There's a hand, here I come. I promise you that if you hold the microphone just with your tiny fingers, you won't get whatever I've got.
Hi, Nathan. You talked a lot about performance inside of the cloud. What do you do to optimize the last mile to the end user from the cloud edge?
I don't know if you saw the Akamai slide deck before me, but they actually had an interesting slide that showed 0.2 milliseconds from inside the cloud data center to the cloud edge, and only 0.2 milliseconds from the end user to their internet service provider. And that they basically optimized the communication between those 2 points. That's about all you can do. You can run some, if you're running a centralized network, you can use some of the acceleration protocols out there. You can go to Riverbed or some of the other providers, and look at WAN optimization. So there are some tools there you can use if that matters to you. It really matters, are you serving a global audience, or do you have a very small audience where you can put in things like symmetrical WAN acceleration products?
Thanks.
Happy customer. Any more for any more? Well, then let's thank Nathan. Go to your breakout sessions. Nathan Day, building the future with SoftLayer. Now.